Welcome class. Thank you for joining me for our 4-4 notes. Now in this conversation we're having this entire chapter on quadratics. One of the important things about quadratics is the ability to factor them. So we are actually going to take the next 3 notes to spend some time factoring. Now before we factor, I want to make sure we remember foiling. So remember foiling is how you multiply out 2 binomial expressions. And what foiling means is the f represents multiplying the first terms, so the x and the x. O represents multiplying the outside terms. I represents multiplying the inside terms. And L represents multiplying those last terms. And once you do all that multiplication, you'll see you have 2 like terms over here to combine, and then you get your standard form quadratic. Now, what we're going to focus on these next couple of days is doing the reverse. We want to start with that standard form quadratic, and we want to get back into the factored form. We want to get back into the form where it's 2 multiplied binomials. So, how do we do this? Well, again, it's the reverse of foiling, and this is something you learned back in exponential algebra in the 9th grade. So, let's review what this looks like. So I'm starting with x squared plus 7x plus 12. Now, I want you to think that x squared term right there, where did it come from? Well, in the foiling process, the x squared came from the f. Okay? It came from multiplying those first 2 terms. Well, so we need to think to ourselves, what multiplies to x squared? Well, when it's just an x squared there, it's actually relatively simple. It's just x into x. So that's where that piece comes from. X times x will give us that x squared. So we know that's going to be the first 2 variables in our binomials. Now, how about that 12? Well, that 12 came from the L, the last terms of each binomial. Now, multiplying to 12, there we actually have some options we're going to have to consider, okay? Because 1 times 12 is 12. 2 times 6 gives you 12. 3 times 4 gives you 12. So here it's not so set in stone. Here we have some options that we're going to have to consider. So how do we decide which of those options we're going to use? Well, if you remember, that is where the O and I come in, the outside and the inside connections. So we look at our 7x, okay? So we need to choose the combination that multiplies to the 12, but then also when we add the O or the I and the O connections, that will give us a 7x. And so obviously when we choose the 3 and the 4, 3 times 4 gives us 12. And then when we make those connections, 3x and 4x adds up to the 7x when we combine those like terms. So I hope you recall what that factoring looks like, how we piece it together. Now, I want you to note that here, when the x squared is by itself, when it has an a value of 1, it is actually really simple to do this process because literally all you're going to get every time is 2 x's here, and then you have to look for 2 numbers that multiply to the 12 and add to the 7. Okay, so this is a very, very basic case, how you always begin learning how to factor. And that little note on the bottom will remind you of that, that when the a is 1, you're literally looking for 2 numbers that multiply to c, the constant, and that add to b, the value with the x. Okay, so let's just step through a couple examples here to recall what this looks like. So if you flip the page, please. So again, all of these examples are going to be that nice case where a is going to equal 1. The x squared term is by itself without any coefficient. So When factoring, I always know I'm looking for my two parentheses. And again, if you think about it, x squared, what gives us x squared? Well, x and x give us x squared. And today, that's what it's always going to look like. We look at the 20. So we have some possibilities that multiply to 20. We have 1 and 20, 2 and 10, 4 and 5. So we have some possibilities going on here, some options. Well, again, the key is we're looking that those outside and inside terms combine to give us 9x. So what are we looking for here? Well, if I choose 4 and 5, my connections will give me 4x, give me 5x, and that does indeed add up to the 9x that I needed. So that is the option that I want to choose. So factors to x plus 4 and x plus 5. All right, looking at our next one. Again, I always begin, I'm just going to set up my structure, my parentheses. So that x squared, where does it come from? Well, x times x. Next, I'm going to focus on the 18. So here we have some possibilities again. 1 and 18, 2 and 9, 3 and 6. Now, I want you to pay close attention though, because we're not really looking for just 18. That is a negative 18. Now, how do you multiply to a negative number? Well, to multiply to a negative number, one of those numbers that I just listed, one number in the pair must be negative. That's going to be the only way to multiply to a negative number. So when I'm choosing the right combination, I have to keep in mind one of my numbers is going to end up being negative. So I'm going to take a look. I'm going to focus on the 3 and the 6. Now, I'm looking here at my combination. So right now, I have 3x and I have 6x. Now, keeping in mind that one of those I'm going to have to make negative, I need to figure out, is it possible to get 3x from that? And the answer is yes. Yes, you can. If I make this a negative and that a positive, I will get negative 3x, positive 6x, and that'll add to the 3x that I need in the middle. So that's kind of the key to these pluses and minuses, okay? To multiply to a negative, recall the way you do that is one number is positive, one number is negative. All right, let's look at our next two examples. Again, the beginning of every problem, I'm just going to set up my structure so I know what I'm looking for. To get x squared, we're talking about x and x. To get 15, we're talking about 1 and 15, 3 and 5. Now, this is another case. Keep in mind, we're looking for negative 15. So whatever we choose, we know one of the numbers in that pair is going to be negative. So I'm going to focus in on the 3 and the 5. Okay? So right now I have 3x and I have 5x. Making one of those negative, is it possible to get a negative 2x there? Well, it is. Because if I make this a negative 5, and I make that a positive 3, that is going to be a negative 5x, and now that's going to add to the negative 2x that I needed. So that's how that one is able to be factored. All right, and keeping this rolling, our last example. I was going to start with my basic structure. Again, x squared comes from x and x. I look at the 72, and I want to write down the possibilities of things that multiply to 72. Well, here there are a lot of options. 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, 8 and 9. So we have a ton of possibilities here. All right. Now, the first thing that I find odd about this one is notice I'm multiplying to a positive number, okay? But the weird thing here is notice that middle number that I'm shooting for, that negative 17x. Well, if I'm multiplying to be positive, you may find it a little bit strange that I'm adding to be negative. Now, the thing I want you to recall is multiplying to be positive. There's actually two ways we can do that. We can have two positives or two negatives will also multiply to be positive. So when I see that I'm multiplying to be positive, yet combining or adding to be negative, I know that I'm searching for two negative numbers right off the bat. All right? So I'm just going to write that in right away when I know that. Okay? Now, I need to look for the combination that will give me that negative 17x. So I already have all my possibilities to multiply to 72. So I'm scanning my list to see which ones of those could add to negative 17. And when I hit the very bottom of my list, I reach those two. So when I multiply this out, negative 8x, negative 9x, that indeed gives me the negative 17x that I was looking for, and that is going to be my answer. All right, so thank you so much for joining me for these notes. Please make sure you have all that written down, and then tomorrow in class we will work on our practice work.